Yeah, good evening, students. So, student, yesterday we did first part of limits, and as I said it to you that I'm going to give the solutions of the yesterday's assignment. At the same time, I'm going to give you one question paper, possibly two, not one. If possible, I'll give two. One is zero level, the other one is what? Mains level. Okay, let us start this. Yeah, okay. Solution for final preparation of limits. Here we discussed 30 questions. Yesterday I gave you the hints. Now I would like to follow those all hints. Right? Clearly, I'll solve these problems. See this now. But extends to 0. What is this? Sine pi is there. Cos square theta, cos square x can be written as 1 minus sine square x. Right? Divided by x square is there. Yes. So if you multiply here pi, then it become what? Pi sine square x, pi minus pi sine square x will get. Of course, limit x tends to 0 is there. This you can write as sine 180 minus theta is nothing but sine theta. Right. So I want to multiply with pi sine square x and dividing with pi sine square x. Value will not be changed. So it is in the form of sine theta by theta, and this is also sine theta by theta. So finally, we got the answer as what? Pi. Okay, this is the first one. Now we'll move on to the next one. Yeah, the second one. When you substitute pi by 2 in this one, in this question, so what we'll get? 0 by 0 form we are getting. But you remember, directly we should not differentiate this type of problem. Directly we should not use the L'Hospital rule. Some changes are required. What are the changes here? I want to take sin x is equal to t now. The moment if I take sin x is equal to t, as x tends to pi by 2, t tends to 1 now. Yes, so that t tends to 1. This is t minus t to the power of t divided by 1 minus t plus log t will get. Okay, this is. Now the question is 0 by 0 form same as it is. I change the structure of the problem. Right. So now this is useful for us to solve the question. It is easy for us to solve the question. If you differentiate, this become what? 1. And whereas here, x to the power of x derivative is what? X to the power of x into 1 plus log x. Here t is there, so I'm writing in terms of t. You see this 0, 1, and this is 1 by t. But still it is in the form of 0 by 0. That's why we are supposed to differentiate once again. Here UV formula I am applying. T to the power of t derivative is 1 plus log t. Already 1 plus log t is there. That's why we are writing 1 whole square here. Minus t to the power of t same as it is. Now this is what? 1 is 0 plus 1 by t we are getting here. This is what? Minus 0 minus 1 by t square. The moment you are substituting 1, what happened here? Minus 1 to the power of 1, 1 plus 0 whole square, 1 to the power of 1, 1 by 1 divided by minus 1 by 1. So finally, minus 2 by minus 1 means 2. This is the answer. Okay, we'll move on to next. Yeah, you see the third question. I gave you the third question like this. Limit extends to 0. 1 plus x whole to the power of 1 by x minus e plus ex by 2 all divided by x square. See, Nana, while attempting this question, one has to know that how best we can write here. See, simply I can write here a final formula, and within 1-2 step we can wind up. I'll show you that formula also. But here I want to tell you that clearly what I did here. So that's why the description is given like this. I have selected this 1 plus x whole to the power of 1 by x and y. You see, the moment I applied log on both the side, I got it like this. Okay, 1 by x log of 1 plus x is there. Log y is equal to 1 by x log 1 plus x I got. Here, because I know this expansion of log of 1 plus x. What is that? This is x minus x square by 2 plus x cube by 3 minus x to the power of 4 by x to the power of 4 by 4 plus so on. With x is there in the denominator, if I multiply inside, I got it in this way. What I did here, this is natural logarithm, basis e is there. The moment I have taken e this side, okay, the moment I can write like this, y is equal to e to the power of this one. Here I use the formula, okay, I separated e to the power of 1 and the rest is like this. Why? Because I want to use this formula, Nana. E to the power of x formula is what? 1 plus x by 1 factorial, x square by 2 factorial, so on. This is. Remember, log x expansion you have learned. Okay, I want to tell you this expansion, and at the same time, e to the power of x expansion also, I want to tell. So that's the reason I got it. I'm going to turn the page now. Yeah, you see this expansion. I'm going to turn the page. I said, yes, I'm turning the page. You see this now. Y is equal to. This is what exponential series formula I wrote. 1 plus x by 1 factorial, x square by 2 factorial, so on. So later on was what I did here. I selected e and x by 2 from this and I separated. I have taken this side and e into the rest is like this. Right. E is into this rest is like this because it will take time. That's why I wrote like this. Now here the question is, our question is this. This is our question. Please remember, that's why I change into this form. The moment I'm writing here in this way, this part I have supposed to write. And in this, from this part, I have selected x square common. Here also I'll take x, I have to take x common, the rest of all. Here if I take x common, the left out one, would be like this. So now x square I cancel here. After cancelling that x square, I substituted the limit value. And for the first bracket, I got it in this way. And for the second bracket, I got it in this way. Rest of all are what you know very well. It will be what zeros are. So finally, what is the left out one? 1 by 3 plus 1 by 8. So when you take LCM, 11e by 24 is the answer. So while doing this question, what you observe means expansions. Expansions also key role, okay, acting according to acting as a major role. So we cannot neglect that one, Nana. Okay, shall we move on to the next question? Okay, see the next question. Fourth question is this one I have given. Right, we can solve in this way, Nana. Okay, what is that? Limit extends to 0. A small change is required before going to adopt a L'Hopital rule. You please remember, I replace this by sin x by what? X. So finally I got it like this. Now here I am applying the rule. Okay, now if we substitute limit value, numerator is what? Not 0, but denominator is 0. Something by 0 is infinity, but here he has given 2. So what is the meaning of that? Numerator should be 0. So the moment you are substituting 0, a to the power of 0 means 1. Okay, and b it is also 1 plus c it is also 1, right? And here that should be what I have taken 0 now. It will be like this. That means a minus b plus c equal to 0. I got it. C equation 1. Once you got it that numerator is 0, denominator automatically 0. So the differentiate once again e to the power of x plus b sin x, okay, minus c to the power of minus x divided by 2x equal to 2. See this now. Once we got it here, once again I want to write the step over here. Limit extends to 0. See this, once again numerator is equal to 0. What happened here? A, okay, plus 0 minus c equal to 0. So a is equal to c, we got it. This is second equation, right? And once you decided numerator is 0, once again we are supposed to differentiate here. Right, once again we are supposed to differentiate. How? See this one, Nana? Limit x tends to 0, a to the power of x, okay, plus b sin x minus c to the power of x minus x by 2x is there, and here it is 2, 1. Okay, we got it once again. Once again you start differentiating here. Once you differentiate, what happened here? A to the power of x again, and b cos x will get plus c e to the power of minus x divided by 2 is 1. Once you substitute the limit value, a plus b plus c is equal to 2, you got it as third one. Right, third one you got it. Already if it is 2, limit value is for 2 here. So then we will get the value of the limit is 2, 2 as given. And it become what? 4. No, no, I wrote unfortunately 1. Nothing will happen. It will be like this. And here he has given what a is equal to c, we know. So I want to express everything in terms of a, or if you want, you can write in terms of c also. Here, right here, right? If you write here in this way, so what is going to happen? See this, Nana? Three questions we got it here. Yeah. Here, second and first one, if you observe carefully, yeah, I can write here b in terms of a, 2a I can write. This is the fourth equation. I got it 2a. So everything I want to write a, b, c, everything in terms of a from 4. See, a as usual, b means 2a, c means what? A again, 4 is there. So a is equal to 1, we got it. Once you got a1, b is equal to 2. B is equal to 1 means c is also what? 1. So your answer is what? Nana? A, B, C is asking. So 1 to 1 is the result. Now shall we move on to the next one? Yeah, here I have to go for, because in this question he has given a step function. So that's why I would like to go with LHL and RHL. Nana. So 1 minus x, this is what x minus 1 step is there. And here 1 minus x is also there. As you know very well, I would like to take here 1 minus h here, small value, okay, negligible quantity. As x tends to 1 and h tends to what? 0 here. So limit h tends to 0. Here, if you change everything in the place of this, if you write 1 minus h, if you write here, you will get what? H here, plus this is minus h you are getting here, and here you are getting what, Nana? H you are getting. First of all, you have to avoid step. So h as usual, I'm not applying limit. Here evaluating this step value, minus 1, and you are getting what? 0 here. Now you substitute. After evaluating the step, whatever you left over, if h is there, you apply the limit, you will get it what? Here minus 1, you are getting. In the same way, limit extends to 1 plus if you take, so right hand limit I am checking here, cross checking here, like this, 1 minus x here. So x is equal to 1 plus h, Nana, as x tends to 1, h tends to 0. So here limit h tends to 0. The moment you are writing 1 plus h here, okay, you will get minus h here, of course. Here you are getting h, and whereas here you are getting what? Minus h. Yeah, as I said it to you that avoiding first. Okay, this is a step function. This is 0 and it become what? Minus 1. Now you apply the limit. What happened? Minus 1. So the result of this one is LHL is equal to RHL. So the answer for this one is 1. Okay, shall we move on to the next, Nana? Yeah, you see the sixth one, Nana. Here, if you take n common, n get cancelled, it will be what? 1, 1 to the power of 1 by 1 plus 1 by n you will get here. Of course, as n tends to infinity, if it is, the 1 by n become what? 0. 1 to the power of lambda is there, right? 1 to the power of lambda is nothing but 1 only, and this is 0. And here, n 1 to the power of infinity form is there. That's why I would like to apply Cauchy's rule. What is that? E to the power of this n divided by n plus 1 whole to the power of lambda plus tan 1 by n minus 1 into Cauchy's formula I'm applying into n. I got it. Okay. Here I would like to turn the page, Nana. See this. You see this now. This n is there. Now actually 0 into infinity form is there. So this n I can write 1 by n form. Now it is in the form of 0 by 0. So the moment I got it 0 by 0, I am going to apply L'Hopital rule, lambda. This is n divided by n plus 1 whole to the power of lambda minus 1. Here, AD minus BC, 1 by n plus 1 whole square formula. Which formula I used here? AX plus B by CX plus D whole dash is there means AD minus BC divided by CX plus D whole square. This is the formula I apply over here, internal derivative. And tan derivative is what? Secant square 1 by n. But 1 by n derivative is minus 1 by n square. I got it. And 1 derivative is 0. And you see this Nana. In the denominator also I'll get 1 by n square. So I want to take 1 minus 1 by n square common and I'll cut it off. The left out one is like this. Lambda. Here also I changed 1 plus 1 by n. You see this Nana? Lambda minus 1. I got it here. Right? This is. And 1 by here 1 plus 1 by n whole square with the negative. With negative. And this is also there. What is that now? Secant square 1 by n is left out. Okay, in the denominator 1 by n square is there minus here whole totally. Okay, multiplied by 1 by n square. Cut it up and simplify. E to the power of minus lambda you will get. And this is what, of course, 1 you are getting. And this is also what? 1. So the answer is e to the power of minus lambda plus 1. You got it. Okay, shall we move on to the next question? Yeah, in this question, you see, I want to rub this one because to get a space. Hmm. So what happened here? You see this now. I want to multiply and divide with 1 minus x. Right, 1 plus x here. X nana this is 1 plus x square and 1 plus x to the power of 4, so on up to n factor. Right, divided by 1 minus x. So it is related to in limit, and limit is related to what? X, not for n, not for it is related to n, not for x. So 1 minus x I'm taking like this. The moment I'm multiplying inside, I may get here 1 minus x square. Here 1 plus x square. The next one is 1 plus x to the power of 4. So on. Okay, n factors. Right. So that 1 by 1 minus x. Right, 1 by 1 minus x I have here. Now finally, what is going to happen? It will go like this. Finally, I want to write here 1 minus x is there, limit extends to infinity. Finally, what happened here? 1 minus x to the power of 2 to the power of n. Okay, whole square divided by, right now, 1 minus. Okay, divided by this 1 minus x is there now. Yeah, if you want, you can write here also, nothing will happen because after multiplying, you are getting that. Right. And you know very well mod x is less than 1. As n tends to infinity, a to the power of n tends to 0 because a lies between 0 and 1. So with the help of this, I can write 1 minus 0 by 1 minus x. So your answer is 1 by 1 minus x nana. I'm going to turn the page nana. For this question, one can easily identify what exactly is going to happen. Here, limit n tends to infinity nana. It can be written as, see, 1 into 1 factor can be written as 2 factorial minus 1 factorial. Okay, 2 factorial into 1 factorial. And 2 into 2 factorial can be written as 3 factorial minus 2 factorial. Like this, the last one can be written as n plus 1 factorial minus n factorial. And anyhow, in the denominator, we have what? N plus 1 factorial. Getting this idea is very, very important. How I got that idea is very simple. 2 into 2 factorial is there. That means 4. 4 can be written as 3 factorial minus 2 factorial. Why I said? Because 3 factorial means 6. 2 factorial means 2. Again, it is what same. So that's why by seeing this one, I got this idea. So that's why I wrote here in this form. So everything get cancelled here now. Only two terms are left out. Limit n tends to infinity. See here, n plus 1 factorial minus 1 divided by n plus 1 factorial. What happened here? 10 tends to infinity. 1 minus 1 by n plus 1 factorial. You know very well 1 by something by infinity is what now? 0. So the answer is 1. I'll move on to the next one now. Yeah, ninth question is given in this way. So to solve this question, what exactly you have to do? It is also limit is also what applicable for n, not for x. Here, I want to rewrite this one quite opposite, उल्टा लिखने की कोशिश कर रहा है यार इस तरह से. Okay, n minus 1. देखो यार ऐसा लिखा cos x by 2 square and cos x by 2. What I did, I wrote this one totally, uh, rewrite this one totally opposite, right? If you consider from first to last means here last to first I wrote. And now I want to multiply and divide with 2 sine x by 2 to the power of n. I want to multiply this in the numerator. Cos x by 2 to the power of n and cos x by 2 to the power of n minus 1, so on. Yeah, I'm writing here cos x by 2 to the power 2 square and here cos x by 2 whole divided by what I'm getting here, Nana, because I multiplied sine. So here also I have to multiply 2 to the power of n. Now you see sine 2 theta formula, 2 sine theta cos theta here. That's why limit n tends to infinity. Next step, what I'm getting here, x by 2 to the power of n minus 1. Here already cos is also there in the form of same as it is, x by 2 to the power of n minus 1. Right, x by 2 to the power of n minus form is there. So 2 to the power of n minus 1. And next one is cos x by 2 to the power of n minus 2. So on, cos x by 2 square, x by cos x by 2 whole divided by 2 sine x by 2 to the power of n. What I'm doing here, I'm multiplying 2. If the process is going on like this now, it will go up to n terms. So what is going to happen? Limit n tends to infinity. Finally, 2 sine x by 2 cos x by 2 is left over, and here 2 to the power of n sine x by 2 to the power of n is there. What we got here at last, this is sine x. 2 sine theta cos theta means sine 2 theta. 2 get cancelled, sine x is there. If I multiply x here, I have to divide with x also. So I'm writing here in a proper way. X it is, this is n, right, divided by this you can write as x by 2 to the power of n. Okay, as n tends to infinity is there. So n tends to infinity means you know very well, a to the power of n tends to infinity if a is greater than 1. I'm using this concept. So, but 1 by a to the power of n becomes what? 0. So this becomes what? 1. So what is the left out one? Left out one is sine x by x into 1 by 1 is there. So answer is sine x by x. Okay. So ninth one is completed now. Now I want to change the page. We'll go for the next question. Here the question, 10th one is like this. So he's asking this. Okay, what I'm doing here, you see this now, limit n tends to infinity. Here f of x means here x divided by 1 plus x, of course. And here x divided by 1 plus x is there. You better concentrate on the second term, Nana. 1 plus here first term 1 plus x. Second term is what? 1 plus x, 1 plus 2x is there. That means in nth term, what is the one which we have here means, right? What is the one which we have means 1 plus, see nth term. First term is what? 1 already is there. In second term, this one. So this is n minus 1 into x and here 1 plus nx. Because in second term 2x is there, na? So nth term nx is there, right? It is one of the easiest way. And of course, here x is there. What is the difference of these two? X is available. Now I want to do, okay, I want to split in this way. X divided by 1 plus x. Here, I want to split this one in this way. 1 plus x minus 1 by 1 plus 2x. This is the one. Like it will go on. And finally, 1 plus n minus 1 into x minus 1 by 1 plus nx. You see, Nana, everything get cancelled. First two terms, if you add here, x plus 1 by x plus 1 you are getting. And the rest all get cancelled. The left out one is the only one thing. Last one, the biggest one, 1 plus nx is there. Of course, this is 1. If you apply the limit, 1 minus 1 by infinity. So answer is what? 1, you got it. Okay, with this 10th one is finished, Nana. We'll move on to the... Yeah, see this, Nana. This question can be solved. Nth term. If you apply sigma for nth term, n into n plus 1 by 2. Of course, if you write r in terms of r also chalega. Okay, for better understanding, I'm writing here n into n plus 1. You take the last one, n is equal to 1 to n, you write, nothing will happen. N cube. Rewriting this, n tends to infinity, sigma n is equal to 1 to n. This is n square, 1 by 2 I'm writing outside, n square by n cube here, sigma applicable in the numerator, okay, plus here sigma n is equal to 1 to n, n divided by n cube is there. As I told to you that yesterday I gave you a formula. In that formula, this is 1 by 2 is already there in multiplication. If we apply the limit here, 1 by 3, whereas this is what 0. So the answer is what, Anna? 1 by 6. We are getting the answer here, 1 by 6. Right, we'll move on to the next one. Yeah, what I'm doing here, x tends to infinity is the question. I'll take LCM, x square plus 1 minus ax square minus ax minus bx minus b divided by x plus 1 equal to 0. What happened here? But x tends to infinity. See this now, x square. If I take common, I'll get 1 minus a. And if I take x common here, I'll get a plus b. The rest is what? 1 minus b. Whole divided by what, Nana? X plus 1 is there. So it is clearly we understood that something by infinity means 0. That means these two terms should not be there. Two terms should not be there means coefficient of x square become what? 0. So 1 minus a is equal to 0. A value we got it as 1. Another one is also that coefficient of x is 0. That is minus of a plus b is 0. So b is what? Minus 1 we got it. A is this, b is minus 1. So final, what is the answer for this? What is asking? Yeah. What is the value of a and b? He said. So the value of a is 1, b is equal to minus 1. We got it. Is that clear, Nana? Yeah, I hope that you understood up to 12. We'll move on to the next one. Yeah, you see the 13th one, Nana. In 13th one, what exactly we are supposed to do? Don't get panic here. Square root is there. You better take down the maximum. X square common. So that if you take x square common, it will be 1 by x square will get. Here you take x cube common because cube root is there. You'll get 1 more x cube root. But here 1 by x and here 1 by x cube you are getting. And then denominator also better take x to the power of 4 common. You'll get x outside. 1 plus 1 by x to the power of 4. Here x to the power of 5 you take common. You'll get x outside. Fifth root of 1 by x plus 1 by x to the power of 5 is left out. Taking x common and cut it off, and whatever the left out one is there. So finally you will have what here? Limit x tends to infinity 1 plus 1 by x square minus cube root of 1 by x plus 1 by x cube after cancelling that x. Fourth root of 1 plus 1 by x to the power of 4, and here fifth root of 1 by x plus 1 by x to the power of 5. What happened here? 1 plus 0 minus root 0 plus 0 by root fourth root of, right, this is cube root, nothing is there here, fourth root here, 1 plus 0, fifth root here, 0 0. Finally what have 1. Okay, we got it this. Shall we move on to the next, Nana? Next. We substitute here, it is in the form of what? Clearly 0 by 0. One of the previous IIT question it is. Okay, NIT in the NIT has given that. So I'm doing that one. Just you differentiate by using that L hospital rule. Right, if you differentiate the same 0 minus 1 by 2 root of cos inverse x, cos inverse derivative minus 1 by under root 1 minus x square, and in the denominator root x derivative is 1 by 2 root of x plus 1. So what is going to happen here? Okay, I'll write one more step. Minus into minus it become what? Plus, and here we have 2 root of cos inverse x and 1 by root 1 minus x and 1 by root 1 plus x divided by 1 by root of x plus 1. X plus 1, x plus 1, 1 by 2, 1 by 2 cancel. Minus 1 if we substitute here, 1 by under root of cos inverse minus 1, and whereas here under root of 1 plus 1. The value of this one, root pi, this is what? Root 2. So finally 2 pi. Root of 2 pi is your answer. Okay, we'll move on to the next one, Nana. See this. 15th one is very simple, right? You better take cos 2x common here. We have here 1 minus cos x is left out, x to the power of 4. Finally, we can write in this form 1 minus cos x if I take common, x square I'm writing here, the limit I'm splitting here several times. Second time, cos 2x divided by x square. So what is the formula here? 1 by 2. Here 2 square by 2. Final, what is your answer, Nana? 1. We got it. Now 16th question is interesting. We'll move on to the next one. Right? We'll move on to the next one, Nana. Here I'm writing. Yeah, question is like this, guys. So very interesting here. What I'm doing, n 3 to the power of n is there. Na? Here also I'm taking the same thing common. N 3 to the power of n I'm taking common. That means x by 2 by 3 whole to the power of n I have to write. Here what 3, right? Here what I'm going to get in this case, n 3 to the power of n means 3 is left out. And 3 to the power of n I have taken here. 1 by n is there. 1 by 3. Chalega. So close the bracket. These two are cancelled. Now the result is 1 by 3 is there. The result is what, Anna, here? By 3 is there. If the result is 1 by 3, I think it is minus 1 by 3. 1 minute, guys. Yeah, it is not 1 by 3, Nana. Here I forgot it to write plus. It is plus. Then it's okay. Right. So if it is plus, then I'll get 1 by 3. The result is match. Then it become what? 0. Okay. It becomes what? 0. When it is as n tends to infinity, a to the power of n tends to 0, provided a lies between what? Mod a is less than 1. There's a rule, no? By using that rule, here I can write x minus 2 by 3 is lies between minus 1 and 1 now. Right. If you multiply with 3, it will be in this form. Add 2 minus 3 plus 2 x 3 plus 2. So what you are getting here? X minus 1 less than, here it is 5. So if I said like this, how many numbers are there means how many integers are there in this one? The number of integers, okay, the number of integers are, you see, 0 is there, 1 is there, 2 is there, 3 is there, 4. So overall, how many? 5. What is your answer? 5 is your answer. Okay, shall we move on to the next? Here I solved. You see, step x lies between n and n plus 1 means the value of this one is what, Nana? N. Step x value is n. So n into sin x by x as 10, okay, tends to n as x tends to 0. But what? Less than n. Less than n. So in the same fashion, n into tan x by x tends to what? N as x tends to 0, but less than n. So what happened here? N minus 1 less than step of x minus sin x by n as x tends to 0 value is what? Less than n minus 1. Less than n minus 1. In the same way, it can be written as less than n. It is more than. Okay? Less than n. So finally what? It will be like this. Okay. If you are not followed, I'll tell you one more easiest way. What is that? See this now. Sin x is less than x less than tan x. This is the rule. What I have here? Sin x by x. It will be definitely less than 0. But if you write here tan x by x, it is definitely greater than 0. So LH, if you take here, if you take in this case x tends to 0, so this become what, Anna? Less than 1. Less than 1 means what? You will get n minus 1 here. Right? N minus 1. Simple, easiest way. N minus 1 here. And tan x by x is there. This become what? More than 1. 1 point something. So what you'll get here? Step of 1.99 also 1. So that n is there, na? N you'll get. Right? So overall 2n minus 1. This is the one of the easiest one. Rather than writing all those things, this is the one of the easiest one to understand in a better way. Right? Shall I move on to the next page, Nana? And next question also. Yeah. Series. related problem. It is inverse trigonometric function. Sir, I want to write this one as tan inverse of like this. Tan inverse of x plus y or x minus y is equal to 1. Okay, minus r plus xy form I'm trying. So if I try in that way, then I have to think about this, what he has given. Let us make this one as a perfect square first. 2, if I multiply, I'll get 4k square. After this, what I'm doing here, limit n tends to infinity, sigma k is equal to 1 to n. See this, tan inverse is there, 2 is there, 1 plus 4x square, okay, minus 1, 4k square minus 1. Okay, 4k square minus 1. Right, right, let me write here clearly, 4k square minus 1. Now, it can be written as sigma k is equal to 1 to n. Of course, limit n tends to infinity is also there. And here it is tan inverse. It can be written as what, Nana? See, guys, how I got that idea, how I'm getting the idea. I mean, 2k minus 1, and here it is 2k plus 1. So when you add here, when you subtract these two, you'll get 2. So that's why I'm writing here 2k plus 1 minus 2k minus 1. So sign this form, I got it. So finally, limit n tends to infinity, sigma k is equal to 1 to n. This is what I know, tan inverse 2k plus 1 minus tan inverse 2k minus 1. Okay, if you substitute the k value, you will get what, Nana? Here it will be like this, tan inverse 3 minus tan inverse 1 plus 1. And the next one is tan inverse 5 minus tan inverse 3. This, it will be like this, Nana. And the last one is, here I'm writing, what is that? Plus tan inverse 2n plus 1 minus tan inverse 2n minus 1. Everything get cancelled except two terms. What are the two terms here? Then n tends to infinity. N tends to infinity, I'm writing here. Please remember. The biggest term is left over, that is 2n plus 1. And the smallest term is tan inverse 1. You know very well, tan inverse infinity is nothing but pi by 2. And tan inverse 1 is nothing but pi by 4. So your answer is what, Nana? Pi by 4, we got it. Shall we move on to the next one, guys? Yeah, you see this, Nana? This is an interesting question. R cube plus 1 is that pi means product of the terms are there. R cube plus 1 divided by R cube minus 1. So what I'm doing here, a cube plus b cube formula, a plus b into a square minus ab plus b square, and a cube minus b cube means a minus b into a square plus ab plus b square. So here I separated this as two different ones. You see, one is this one, the other one is this one. And I split the limit also. Here I substituted the constant values. If I substitute 2, I'll get in the numerator 3, 4, 5 up to n plus 1. Whereas in the denominator, I'll get 1, 2, 3 up to n minus 1. In the same fashion, here also if I substitute the r value 2, if I substitute here 2, I'll get 3 by 7. The second 3 by 30, 7 by 13, like that I'll get. So what I understood, the similar terms are in this way. I cancel here. You see this? It has taken time. That's why I did it previously. So here I cancel these terms in this way. So left out one is what, n into n plus 1 in the numerator here. In the first case, in 1 into 2. In the second case, 3 by and then n square plus n plus 1 is left over. I have taken n square common here. 1 plus 1 by n. I got it in the denominator also same. Cancel n square. Left out term, what is there? As n tends to infinity, 1 by n tends to 0. That's why I got it here. 3 by 2 is the final answer. Okay, now we'll move on to the next page as well as next. The interesting question here. I think this is based on existence of limit. A2 minus is there. What is going to happen here? X1 minus A1 by mod. X1 minus A1 and X1 minus X2 minus A2 by X2 minus A2 mod. And here X3 minus A3 by X3 minus A3 is there, mod is there. So what is going to happen means very simple, Nana. X tends to A2 minus is there. So A2 means, of course, A1, A2, A3 are A1 is less than A2 is less than A3 is there. So that's why x1 minus a1. This is also positive. Positive now because a2 is much greater than a1. But second one is negative. a2 and here x2 minus a2 if I write, I'll get minus. And the third case is also what? Minus. x3 minus a3 divided by minus x3 minus a2. What happened here? Everything get cancelled. What you have? 1 into minus 1 into minus. We got it as 1. Now move on to the next one. Limit extends to a2 plus. So x1 minus a1 directly I'll write here. I hope that you got it clear idea. x2 minus a2 divided by x2 minus a2. But this is next one. x3 minus a3 divided by x3 minus a3. So everything get cancelled. What is the left out one? Minus 1. These two are not equal. Does not exist. Does not exist. Okay, I'll move on to the next one. Guys, to solve this question, one of the easiest point you have to remember, limit n tends to infinity, f of n plus 1 is same as limit n tends to infinity, f of n. Say something k. So what is going to happen if I apply limit here? This is k, 1 by 2. This is k. This is what? 9 by k. We are getting here. So when you take LCM, you will get what? K square. That is 2k square you are getting here. This is k square plus 9 meters. Yeah, k square plus 9. Writing in this way. So k square is equal to 9. K is equal to what? Plus or minus 3. We got it. K is equal to how much Tana means? K is equal to plus or minus 3. We got it here. You are asking that f of n is positive, so that k value will become what? 3 is a resultant answer. We'll move on to the next one, Nana. 22nd one. See, rth term he has given like this, Nana. R divided by r to the power of 4 plus r square plus 1. And he's asking limit n tends to infinity. It looks say the simplest one, but definitely it will take much more time, Nana, because here we have to think in a different, little bit different. We need not worry. Okay, I'll turn the page. What I'm doing here, to solve this one, I'll consider two different functions now. One is, let us take down here f of n it is. What is that? I substitute the values here. 1 by n square plus n plus 1. Second one, 2 by n square plus n plus 1. 3 by n square plus n plus. This is 2 nana. This is 3 nana. It will go like this up to n divided by n square plus n plus n. Yeah, I want to consider one more formula. What is that? Consider. I want to consider one more function g of n. It is a like replica of this, but small changes is there. N and here n I'm taking here. 2 divided by n square plus n plus n I'm taking here. 3 divided by n square plus n plus n I'm taking here. Right. You see, I'm constructing. Getting this idea, I know very well that getting this idea is a bit difficult, but even though, right, if you select, if you think in this direction, it will be good. Otherwise, it will create a lot of problems to us. So better if you got this type of question, solve in second round, not in first round. N square plus 2n, we got it here like this. After simplifying this one, we got it in this. So clearly, what I'm saying here, clearly, it is very clear g of n is definitely less than because f of n. This is the one. This is the idea which you are supposed to get here. Okay. And I want to take one. Similarly, in the same fashion, what I'm doing here, you see that. Similarly, h of x, h of n also I'm considering. What is this? 1 by n square plus n plus 1 and 2 by n square plus n plus 1. Right. So on like this. N divided by n square plus n plus 1. See the difference. Here 1, 2, 3 is there. Here I consider n such a big number. That's why compared to this, it is like this. But if I take smallest one in the denominator, that means 1 if I take here, it will be in this formula. What is that? 1 plus 2 plus so on plus n divided by n square plus n plus 1. That is n into n plus 1 divided by 2 into n square plus n plus 1. I got it. Now what is that comparatively f of x, right? H of n is such a big number. This is 2, right? So what happened here? Limit n tends to infinity. If I say g of n, if I said the value of this one become what? 1 by 2 number. You know very well. Highest coefficient. Coefficient of highest power of n divided by coefficient of highest power of n here, n square. In the same way, if I write here limit n tends to infinity h of n, then it is also 1 by 2. So I'm applying sandwich rule. What is that sandwich rule says? We got it like this. Okay. Limit, you see this now. What is that? F of x. Okay. F of x here in the middle I wrote. And this is what? G of x. And this is h of x. Right. I got it like this. Limit n tends to infinity g of x less than limit n tends to infinity f of x. Limit n tends to infinity h of x. As you know that these two are, this is 1 by 2 less than, this is also 1 by 2, whatever is there. According to sandwich theorem, what you can say, limit n tends to infinity f of n is also 1 by 2. So wonderful question, but getting that idea, and it will take, yeah, one is a lengthy question, but it is easiest one. Why? Because square root 1 to the power of 1 by 2 there, 1 by 2 power, here also what 1 by 2 power it is. So what I did here, I rationalized this numerator. When I rationalize here, this become what whole square will get done. So this 1 by 2 square get cancelled and the left out terms are like this. Some of the terms are get cancelled. This is gone. And whatever is left over here, from this I have taken n square common, n common, and the constant I wrote like this. Denominator as usual. Here from the numerator also I have taken n square common, and the denominator also I have taken n square common. Whatever it left over is like this, and as n tends to infinity, 1 by n tends to 0, nana. That means this is 0, this is 0, and these all terms are 0. These all terms except 1. Here 1 is there, here also 1 is there. That's why I wrote here 1 plus 0, 1 plus 0. So answer is a1 minus b1 by 2 e coordinate. Now we'll move on to the next one, 24th one. 24th one is interesting one. It will create a phobia. It is a great difficult one. Okay, it looks like that, but not. What I have to do here? See this now. What I'm doing here in the case of this. See, first of all, whatever he has given in that I'm taking x is equal to y is equal to 1. I'm substituting. That means I'll get f of 2. That is f of 2 means 1 and f of 1. Because 1 means 1. So 1 plus 1 is what 2. So same as it is if I write here 3. That means 2 plus 1 I'm substituting here. F of 2 plus f of 1. Then it becomes 2 plus 1. Recalculating. That means f of x is equal to what, Nana? X is a function. Simply. So here I'm turning the page. So limit x tends to 0, 2 to the power of, simply I can write here. What is that? Tan x. Right. 2 to the power of sin x. Here. Okay. X is there. This is what sin x. What I'm doing in this case, when x tends to 0, see this now. 2 to the power of sin x I'm taking common. So 2 to the power of tan x minus sin x minus 1 I'm getting. Right. And here I have x square sin square x. I'm multiplying. You see this? Tan x minus sin x I'm multiplying and dividing with tan x minus sin x. Nothing will happen. So finally I'll rearrange this. That is 2 to the power of tan x minus sin x minus 1 divided by here tan x minus sin x. Yeah, this. And in the case of this one, you see this now. 2 to the power of sin x is there, f dot 1. And one more is there now. What is that? Tan x minus sin x divided by, okay, x square sin square x. Right, x square sine square x, we got it here. Now what I'm doing here, I'm taking sin x common. Limit x tends to 0, to the power of tan x minus sin x minus 1 by, this is tan x minus sin x, and to the power of sin x, here it will be like this, cos x by x square. And of course, this is there, na? Yeah, you can write here. Right? 1 by, yeah, after taking sign common, on sign you take common, right? Here sin x is there, that sin x will get cancelled. So 1 minus cos x by, here we get what now? Cos x. Right? I'm taking sin x common here. So I may get this as what sin x, 1 by cos x minus 1. 1 minus cos x I will get. Like this, divided by x square cos x. Here, it will be sin x only, not x square. Okay, sorry guys, I wrote extra, right? Done. Yeah, it is sin x only. Here sin x, here also sin x is there. I cancel sin x. This is one formula, and to the power of sin x means nothing is there. So this is what log 2. This is 2 to the power of 0. This is 1 by 2, 1 by cos 0. So your answer is 1 by 2 log 2. Okay? Yeah, we completed this one. Nice question this. See this now. This question is, it looks like a little bit difficult one, but you have to take care of this. What I did here, in this question, root cos 2x, cube root of cos 3x, 4 root of cos 4x, and the root of cos nx, that I have taken as y. And after that, what I did here, applying log on both sides. When I apply log here, I got it in this way, and so I started differentiating this one with respect to x because I want to apply L'Hopital rule. Right. That's why when I differentiate here, log y means 1 by y dy by dx, and this is the derivative of this one is log cos 2x means 1 by cos 2x, cos 2x derivative is minus 2 sin 2x. In the same way, I did it for all the terms. And here I've taken all this 2, 2, 3, 3, and then get cancelled. Left is what this. Here I substituted. This is nothing but product now. So pi I wrote, square root now. So 2 to n, and cos rx whole to the power of 1 by r is there. And this term I wrote in this way. So finally, what exactly he has given? He has given like this. Now I want to apply L'Hopital rule here. The L'Hopital rule, if I apply here, I got it this term. Please not forget about this. So that I am going to write. Shall I turn the page? Yes. Shall I turn the page, Nana? Yes, I'm done. Yeah, this can be written as x tends to 0 minus pi r is equal to 1 to 2 n cos rx whole to the power of 1 by r. I'm not going to touch this. I differentiated. Na? Moment I differentiated here by L'Hopital rule, this in the denominator, I would like to get, I may get here 2x, not x squared 2x. And this is minus tan 2x, tan 3x, like this, minus tan nx is there, and divided by what we have, 2x. So what I'll get here, 1 it is, and finally, this is 1, we got it here. Here minus 1 is there, minus into minus is what? Plus we are getting. So this become what? 1 only. Product is there now, 1 only we'll get. And whereas here, if I apply limit, x tends to 0, see this now, tan 2x, tan 3x, so on, tan nx divided by x is there into 1 by 2. So what I'm getting here, 1 plus 3 plus so on plus n into 1 by 2. This is nothing but n square plus n minus 2 divided by 4 I'm getting. But given, already what he has given, minus 2 by 4 is equal to 10 he has given. So that n square plus n minus 2 is equal to 40. So finally, We got it here. N square minus n plus n minus 42 equal to 0. 7 6 are 42. So n is equal to minus 7. N is equal to 6. Positive one is n is equal to 6 is there. We got it now. Okay, 25 questions we did it, guys. 27th one. Why I selected to tell you that this is variable, this is constant. Right. X to the power of x derivative is, you know very well, x to the power of x into 1 plus log x. Here y is constant, Nana. So what you can write, x to the power of y means x is variable, y is constant. Y x to the power of y minus 1. Here y to the power of x log y will get divided by, here x to the power of x means x to the power of x into 1 plus log x. And y to the power of y means 0. Substitute y. Okay, here y to the power of y minus 1. Here y to the power of y and log y divided by y to the power of y 1 plus log y. So you got it as 1 minus log y by 1 plus log y. You got it. Right? 26th one. Yeah, guys, you see this question is given here. First of all, we have to write f of x. And afterwards, limit extends to a. He said that f of x. He said that third does not exist. How many cases? Right. I'll turn the page and write Nana. It is one of the easiest way when you factorize this. Okay, when you factorize this, x minus 1, x minus 2, x minus 3, I'm getting here like this. So here I am going to decide. How to decide means very simple. And you plot this 1, 2, 3. How many cases? 4 cases. 1, 2, 3, 4 cases. I'm getting. This is what greater than 3. If I take greater than 3, you would select any one value. Say 4. 4 you substitute here inside this. What happened now? Tell me. All are positive. So positive. When you are getting positive, positive by positive is 1. This is 1. We got it. And 2 to 3 now. Here I am taking 2 to 3. 2 to 3 means 2 to 3 means this is positive, this is positive, this is negative. That's why I got it negative here. So minus 1 I got it. And next one is what? 1 to 2. 1 to 2 means, once again, 1 to 2 means two things are negative. 1 to 2. This is positive, this is negative, this is negative, positive. So that's why 1 I got it. Less than 1. All are negatives. Right. So that once again I am getting minus. So that I am getting this one. So the moment you are applying limit at 1, minus 1, LHL minus 1, RHL 1. So limit does not exist. X is equal to 1. In the same way, 2 does not exist. In the same way, 3. So how many points are there? 3 points are there. Like this, I did it now. Okay, 27 1. Yeah, interesting question, guys. Nothing is there here. If you substitute 2, 0 by 0, you're getting don't differentiate. Necessarily you'll land in trouble. You multiply 3 to the power of x, and denominator in the numerator, you multiply 3 to the power of x. The moment you are going to multiply 3 to the power of x, what is going to be happen here? You see, Nana, it will be what? 3 to the power of 2x, 3 to the power of here 3 cube is there, 27 you are getting. Is it 2, 3 to the power of x? In the denominator also, you will get like this. So here we will get 2 factors here. Okay, time is not permitting. That's why I'm doing like this. This is like this. Now, after 2 factors, this again I wrote this at a square minus b square formula. A plus b into a minus b, these two gone, and I substituted limit value. I got it here 36. Only 2 problems are left here. After that, I would like to give the question paper to you guys. Right. Now you see here, I'm writing the question. Clearly 2 to the power of plus 2 extends to 2 to the power of plus 2 plus means you'll get what here? 2. 2 cube means 8. 8 by 3. Here 2 if I substitute, it is what? Fraction. So it is 0. Simply you can write 8 by 3. Right. 8 by 3. If it is extends to, if it is like this 2 minus if I say, then the story is little different now. This x by 3. See this cube is there now. 2 minus if I say, then it is 1 by 3. Here, anyhow, it is 0. 2 minus means anyhow, it is 0. So 1 by 3. Limit does not exist. But he asked only RHL. So answer is what? 8 by 3. your answer. Okay, guys. So one more question. Yeah, see this now. X is equal to 2 minus h. If I write limit h tends to 0, this is 2 minus 2 plus h you will get here 2 minus h minus 2. Of course, this is 2 minus h here. So what is going to happen here? Limit h tends to 0, step h and step minus h minus 2 plus h. So you are getting 0 minus 1 minus 2 0. So minus 3. RHL limit h tends to 2 plus 2 minus x plus x minus 2 minus x. So x is equal to 2 plus h. If you take limit h tends to 0, 2 minus 2 plus h minus here minus आ जाएगा यार यहाँ पे क्या होगा देखो 2 plus h minus 2 2 minus h. So anyhow here minus 1 you are getting, here we are getting 0 minus 2 and 0. So minus limit is exists and the value is what? Minus 3. So with this I guess I discussed the thorough paper. Now I am supposed to give question paper to you, Nana. Yeah, here are the question 25 questions in this. As I promised to you that after discussing this all 30, I would like to give one paper, if possible two, but not at least one paper I would like to give after this, right? So please practice well and try to get the answers. Okay, right. Here I'm going to give the question paper. Yeah, question paper, you see this, Nana? The first question is like this. I selected the question from 2024 questions. First one is this. Second one is, I think this is very clear. Third one is this. You're supposed to find a B cube value. Third one is this. Okay. 2 alpha minus beta value you have to find. Fourth one is this now. Whether it does not exist, r minus 1, 1 and 2 for option C. And here are in AP, consecutive terms of AP, these exist. Its common difference. And what is the value of this? This is d nano. Under root of d, this 1 by d it is. Product of four consecutive terms here are given here. Under root 2 1080. And if alpha beta are the roots of the equation. This and this one is given. What could be the value of k, but in terms of beta and alpha, where alpha is defined. Here beta is defined here. I'll turn the page. And here is given. And in this 5a square plus b square value of defined. And this is what you have to select one of this value. And then here plus number here. 8 alpha plus beta is asking tan inverse of this value. You're supposed to find. I think it's not the rational part now. Integer first bracket it is. And what will be the value of this one I asked? Here I defined alpha, beta. And finally, I asked AB. And what is the order play which is satisfying this I asked? This is step function. What could be the value of this I asked? And this is step function. There will be two more questions I've given, 15, 16. And some bookish questions, some book I've selected some question. And those questions are this. Step function related. And some sequence it is following this and this. And some timing number related question. Again, this is a product of terms. And what will be the value of this you are asking? And these are the three problems are there in this 4 problems, 22, 21, 25. And here I have given okay. So as I said it to you that I discuss complete all all formulas, and then afterwards all types I discussed. And 30 question assignment yesterday I have given. Today I have given the solutions of the 30 questions. And I have given here one question paper. 15 question from PYQs, 15 from different books. Right, I have given. Those whoever are going to follow this order for all the topics, whatever the important topics yesterday I discussed, I think they are going to get far better marks. There is no doubt. And the best rank they may get in mains. So, all the best, guys. Be careful. Okay. In the next class, we'll go first. Second year topic I would like to discuss on. Bye.